Hello and welcome back to TechnoSearch YouTube channel. So NVIDIA's GDC conference has been over and we got some massive details or massive things to talk over. First of all, it's regarding the improvement because NVIDIA is planning for the performance uplift for the next generation, like next few generation. They compared it with Pascal till Blackwell, and there they said it's a 10x performance uplift, and they are planning for the next 10 years to increase the performance by 100 times. They are saying 100 times the performance, but it is in comparison to Pascal, so it's technically like 10 times more powerful than Blackwell. But it is also truly insane because Blackwell is faster, but what it will be is the major thing to see is it still an AI upscaling or pure performance, pure rasterization performance is to be seen. Next up, we have some news regarding DLSS 5, as NVIDIA has already shown off the DLSS 5. DLSS 5 delivers AI powered breakthrough in visual fidelity for gamers. So first time ever, this is not based on raw performance but visual fidelity, but there's a caveat. As you can see on the screen here, it uses DLSS 5 and motion vectors and colors to generate the image or generate the game. Here in this scenario, 3D graphics at 4K. But when you see it in Resident Evil Requiem, the character model looks nice, and this is the artistic integrity where the developers want it to be seen like this. But you see when we turn on DLSS 5, it looks very different. The character model is changed a heck lot, which is not that good looking. As you can see, the character model looks, the lips are too much, the hairs are too bright. As you can see, the artistic model is changing, and you can see the lighting has been improved, the visual fidelity has been improved, like it looks real, but at the same time it looks bad because its games are sometimes designed in a way where it should convey a particular scenario. As you can see here, it's dark, it's gloomy, but when you turn on DLSS, the lighting has been changed to it's too bright, and it doesn't feel that the intent of the developers are there. As you can see, the character model has been also shifted a lot. Same in this scenario with Leon. As you can see, the character model has been changed, the darkness has been changed a lot. The same scenario happens with EAFC. As you can see here in this character model, the visual fidelity has been improved, but it looks real, but at the same time the art style is gone. Like it looks real, which is nice, but at the same time it will look like all the games are going to be real. As you can see, all the players look the same, their looks photorealistic, but then the artistic how the games should be conveyed, the artistic probability is going down. As you can see in Starfield, okay, the game engine is years old at this current point of time, and they should fix the game engine. Medusa should do it. But as you can see, originally with DLSS off, it looks like this, but when you turn on, the character model is literally changed a lot compared to how the character model is, and it looks too bright. The scenario where this is a spaceship, and when you turn on, it doesn't even feel like a game, it just looks like a movie at this point of time with that visual fidelity, which is not good. As you can see, the character models needs to be looked the way the developers intended, and here if you see it, the DLSS literally changed the character model completely, and it feels like an AI slop. And here also it's the same scenario. Along with it, in Hogwarts Legacy also you can feel the same thing happening with these two character models. As you can see, the character model for the goblin has not been changed, but for him, it's changed a lot. And here also the same thing happens. As you can see, the character model has been changed a very bright environment, and it doesn't looks that good. It looks fine in a visual fidelity way, but it doesn't portrays the same thing which developers want it to provide. And this just feels weird. The technology is good, but when you consider the drawbacks, it's not looking good. bright. As you can see, the character model here is also changed a pretty big, and one of the major difference for game development is the character models and the lighting, because if every game becomes photorealistic, then there's no need to buy another game. As you can see, if everything becomes photorealistic, you will not play Assassin's Creed, or you will not go for any other games if they become photorealistic in a way the character model is like too real. So yeah, it is still in early and people are saying it's an AI slop, though NVIDIA came out and said that it is not an AI slop. And the thing is, with DLSS 5 APS and SDKs, the developers will have the complete authority to tune how the character model will look like, which is remaining to be seen when DLSS 5 launches later this year. We will see about it and I will keep you updated regarding it. And there's a lot of optimization to be done in DLSS 5 segment, as DLSS 5 is not that well optimized, because the GPU which needed to run DLSS 5 were 2 pairs of RTX 5090. Yeah, you heard it right, RTX 5090, which is their high-end graphics card, and they need 2 pairs, like literally 2 graphics cards to run DLSS 5, which is insanity. Next up, we have some news regarding the next generation Medusa point, as it has been spotted as the testing for the Medusa point on Plum FP10 motherboard has been spotted with NVIDIA shipping manifest. As you can see, one of the Zen 6 CPUs has finally been spotted on Geekbench. It is a 10-core CPU. As you can see, it has been spotted with AMD Plum. Plum is the code name for the next generation and next generation architecture, and as you can see, it's an engineering sample. It is 10 cores, 20 threads, 2.4 GHz base clock, and the maximum frequency is 10 MHz, but it is an engineering sample, so it will go way higher. 32 megabytes of L3 cache has been confirmed, and as you can see in this manifest, it has been spotted 64-bit microprocessors, and these are the model numbers which is already seen over in the Geekbench benchmark. Along with it, we have some news regarding RDNA 5, and AMD's RDNA 5 may make dual issue easier to use according to the new LLVM changes. And what it essentially is, as you can see, RDNA 5 GFX 1310 VOPD added instruction set for V max min and V sub, extracting the maximum and minimum values of integers, subtracting instruction and bit shift operation. In simple way, what it does is, traditionally the single core is responsible for doing one arithmetic computation at the current point of time, but RDNA 5 could use more than the older design, as the change appeared in the LLM pull request. And the main point is that the AMD's new earlier dual issue setup had a lots of limits. It only worked with a small list of instructions, needed wave 32 mode and various other things, and extra register rules that could block it from working. But now AMD might be able to do it, as some benchmark tools such as VKpeak could show only about half of the GPU claim peak FP32 performance in certain tests. The new LLM VM code suggests AMD is adding support for GFX 13 through new entries of GFX 13 Gen D and Gen D3. That means RDNA 5 is getting updated dual issue instruction handling, including support for more operation than before. The patch also adds GFX 13 specific test files, so this looks like an actual feature update, not just an early placeholder. And what it essentially means is it will do 2 arithmetic computation at a single point on a single core, which is a massive uplift. And if the rumors by Mosley is that is true, which previously he said that it will go as high as 154 cores or CUs, compute units, so it will be equipped, and with those 2 arithmetic operation at this on a single core, you are essentially getting more than 154 cores. You are essentially getting upwards of 308 cores in the high-end segment, and this would blow past the performance or arithmetic performance of RTX 6090 or RTX 5090 if we consider current generation. and if it blow past RTX 1690, this will be computation to the high end, which is literally needed. And the major thing is, I'm saying arithmetic computation, but this computation is necessary for pure rasterization performance and not ray tracing or any other performance or AI performance. It is pure rasterization, so the games will be delivering more frames, more FPS in native resolution, whichever you want it. But yeah, that's it from me today. What do you think about the news? Sound off your thoughts in the comment section down below, and I'll meet you in the next one. Peace out.